So it's pretty cool. You can actually run MicroPython, a version of Python on the ESP8266 controllers. It's even better on the ESP32 controllers, but this is, you know, I basically had this board floating around for about 5 years. They were like $5, $8 a piece. This one's got a bunch of IO pins. I could run a servo off of it, and then I've got a little relay on here. I actually did a project a long time ago where I did some C code, and now I'm going to do the same project with Python code because it's a lot easier for me to develop with. So our goal here is to basically flash that, and what we needed for this was my compatible board, and this one's similar to a Wemos D1, and USB to 3.3 volt adapter and cable, and a PC with a USB port and internet access so I can download stuff. In my case, I've got this old hack cable, which might actually be counterfeit. There was a few years where you ended up, a lot of stuff what you bought was counterfeit. Anyway, so this one actually doesn't work on a PC, but it works on a Mac. But I would recommend you use something with good drivers. And then basically what we're going to do is we're going to flip this jumper into program mode. We're going to erase the flash, and then we're going to restart a couple once, and then we're going to write MicroPython to it and put it back in run mode and demonstrate that it actually works. The MicroPython works using the REPL. If we look at one of these, so I have a USB prolific adapter for this, and I wanted to get a feel for which serial port, USB serial port, my device is now plugged into, right? So I have this device, you can see this cord coming off, and that actually is plugged into a prolific adapter. So the first thing we always do is we actually erase the flash. So I'm going to cheat. And I'm just going to copy and paste that in here, and that will erase the flash, and we'll see if that works. Nope. So the first thing we do whenever we look at one of these is we erase the flash, right? When we're going to reprogram it, it just works better if we erase everything. That way you don't have any weird stuff hanging around. So I'm going to do that. That's basically what this command is. So this is going to erase the flash. The next thing we're going to do is we're going to put MicroPython on it, right? So now that this is finished, what I'm going to do is actually, because I'm weird and I had problems with this adapter, I'm going to unplug and replug everything back in to reset it. And then what we'll do, you know what, let's just clear that. Then what we'll do is we're actually going to try and see if we can get this whole flash thing. Last night I didn't have a problem with this, and of course now that I'm making the video, we'll see if it works. 11%, that's good. This is a good sign. So first thing we did was we erased the flash in this thing, and now we're going to flash MicroPython to it. When this is done, I'm actually just going to open a shell to the command line REPL, the REPL. And then we'll just make sure that Python's actually on this thing. All right, we're getting close. And then what I'm going to do is move the jumper back to run mode. So let me unplug this. Everything in my case, because I had a problem. So now I showed this before, but the idea is I actually have to move the run program jumper, basically tying to 0 volts, so 3.3 volts, GPIO 0, that tells it whether to go into program mode. And then I'm going to plug it back in, so now it should actually bebop onto MicroPython. So let's do R shell. I use R shell for everything. So in this case, I got to figure out, so I can drop into the Python command prompt, I need to do connect serial dev/cu.usb dev. All right, so now I'm actually in this. You can actually see I connected. That means I'm connected to the Python interpreter. Actually, I'm not connected to the Python interpreter. I'm connected to the board. And all the boards come up with the name PyBoard because the company that creates MicroPython sells a board called PyBoard. And so now I could say like ls/PyBoard This shows me the file system on the PyBoard. You can actually see here that there's just a boot py file, right, which actually turns off the debug mode. And then if I go into REPL, I can actually do like, I don't know, print. And it works. Now I have a print statement. I hit Control X to get out of that. And in my case, what I would do now is start copying files out there to run them. So in this case, I would do like, you know, cp config.py/pyboard, cp connect, and I'm just going to copy all of these to get them to run. Remember, you can rename your board to something else, but /pyboard is the default. cp main.py/pyboard, cp toggle.py/pyboard, cp web server. All right, and because of the way, ls/pyboard. So we can see we have 6 files that I copied out there. Basically all the files are out there now. So if I were to restart this thing, it'll actually boot up the main program and it'll actually bring it up. So that's it. The whole goal here was to show burning Python into a little ESP8266. I hope that worked out.